So now we'll see how the base SAS environment looks like. We'll type some small code and see how that code is getting compiled and executed. In case if you're making some mistakes and if you're getting errors, how to resolve those errors, and we'll try to get used to this particular environment. So if you see this SAS environment, there are three windows open. So we have something called as SAS editor window, then we have this log window, then we have this output window. So this editor window is something where you'll be writing your code, and again, as I said, that code won't be a huge amount of code. It will be only few lines that you'll be writing, where you'll be calling some predefined SAS procedure or function, and you'll be supplying your data sources that you want to analyze and generate meaningful reports and do some analysis on those data sources. So in this editor you'll be writing your code, then you'll be either pressing F3 button in some SAS versions, or you can even click this particular icon which is shown here, the stickman icon, and submit your program for compilation and execution. In case if there are errors and mistakes in your program, those errors and mistakes will be shown here in the log window. Otherwise, you'll see how many rows and columns have been processed by your code that you have written. Again, there are several terminologies that we are going to use now. So as you must be aware of the terminologies like tables, rows and columns, we'll be using similar terminologies here in SAS. So for table we are going to use a terminology dataset. For observations, for rows we are going to use a terminology observations, and for columns we are going to use a terminology variable. So once your code compiles and executes successfully, in this log window you will come to know how many observations, that is how many rows, and how many variables, that is how many columns, have been affected by your query or the code that you have written, and output will be shown in the output window. One can write the code in this editor which is called as enhanced editor. Apart from this, there is one more editor which you can access by clicking this view menu. So in view menu you have something called as program editor. The program editor also looks like similar to this enhanced editor. This program editor is a generic SAS editor which is available in almost every operating system for writing SAS code, and this enhanced editor was particularly designed for Windows. In terms of user friendliness, when you are working in Windows environment, this enhanced editor will be a better experience than this program editor, because as in when you type something in this enhanced editor, for example, we have a procedure to sort our data. So the moment you type something, okay, if it is a misspelled keyword, it will automatically turn to red color the moment you type. If it is a correct keyword, it will automatically turn to blue color. So such things would be there in program editor only after completing the code, but in enhanced editor, the moment you type your keyword and if it is not spelled correctly, it will turn to red color. If it is spelled correctly, it will turn to blue color. So it's easy to diagnose errors and rectify them in the enhanced editor compared to the program editor. Program editor you will come to know only after completing the code. So this is how you can write some code in the SAS environment. So we have a procedure in SAS called as proc print, which is used to read your data sources and write a report format in this output window. For example, I have some data sets or tables stored in one of my hard drive locations. Okay, so let me show you. So in C drive of my system, I have a folder by the name SAS Foundation. In SAS Foundation, I have a subfolder which contains large number of data sets. I have these data sets which I have created for a fictitious manufacturing based company. So we have lots of data sets or tables like customers and employees and suppliers and products, we can use one of these data sources. So I have my data sources available in different format. I have some of my data sources in CSV format, I have some of my data sources in DAT format. These are the raw file formats. Apart from this, I have some of my data sources in SAS format. If you go to your hard disk location and see files with extension SAS7BDAT, those are the files which are representing SAS datasets. So I have a file by the name cells.sas7bdat. This is my SAS dataset. So if you see this file, there is something called as cells.sas7bdat. This is a SAS dataset file. A dataset on your hard drive is stored with extension SAS7bdat. Let's see what data is contained in this particular dataset. For this, I am going to write a simple code which is going to read this dataset and fetch the data from this and display it in my output window. So this is the code that I am writing. Proc print data is equal to, specify the path where your data set is stored. So I say C colon SAS foundation PRG1, and then you specify the name of the data set. Only name is enough, extension is not needed. So just specify the name of the data set, C colon SAS foundation PRG1. The name of the data set is cells, and then you write a keyword to end your code. So basically in SAS, when you write a program, your program comprises of something called as steps, and there are two major steps in base SAS. We have something called as proc step and data step. Proc step is used to analyze your existing data sets, report on existing data sets, generate some statistics on existing data sets, and data step is primarily used to create new data sets. I'm assuming that I already have some data sets that I'm using for my reporting or analysis. So I've written a simple proc print statement where I'm specifying the name of my data set, and then I'm ending this particular step by writing this keyword run. So when I define a program in SAS, a program is basically a collection of steps, and a step is collection of statements in SAS. So here I have written a step which is a proc step which comprises of two statements. If you want to identify a statement easily in SAS, you just look for the semicolon. So a semicolon is basically which is used to end a statement in SAS. So this is my first statement, this is my second statement, which is called as a step boundary, that is used to end a step, and this is my complete step which I am going to submit for accessing that particular data set and creating a report which will be displayed in the output window. So as you see in the output window, there is a report generated. It seems in that dataset cells I have around 165 rows, that is 165 observations which are printed like this. So if you just scroll this up, these are the variables or columns I have in my dataset cells. So there is a variable by the name employee ID, there is a variable by the name first name, last name, gender, salary, job title, country, birth date and hire date. So what my procedure has done here, it has connected to this particular data set, fetched data from that particular data set, and that data is displayed in a report format in the output window. So as you see, there is some report displayed in my output window, and in my log window I am getting some messages saying how many observations were read from my input data set and how my report is generated. At the same time, even the code which I submitted for compilation and execution is printed in the log. If I commit some mistake here, say for example if I don't terminate my first statement, this is going to result into an error. as you see here, because of that missing semicolon, my step or program that I have submitted for compilation has generated an error. So the error is for the semicolon. The moment you specify the semicolon, the error will vanish and the program will start executing. It is a good practice to clear this log window and output window always before you submit your program for compilation and execution. We have a shortcut in SAS to clear this log and output window, Control plus E. So hold down the Control key and press E, and that's going to quickly clear your log window. It's always a good idea, as it is good to read the messages, fresh messages which are written in your log window and the fresh output which is generated in the output window, rather than scrolling this down or up to check your output. So press Ctrl E, and by that you can clear this log and output window and submit your program again for compilation and execution and see how the program is generating this result. So that was one common mistake which generally people do when they write SAS code in this editor. Okay, the missing semicolon. There are other types of errors. For example, when you misspell a particular keyword, when SAS failed detecting a keyword, it's going to display you an error message. For example, instead of the keyword proc, I have written pro here, which is a misspelled keyword in SAS. SAS will fail detecting this particular keyword and will throw an error in the log window. But there are certain mistakes in SAS, there are certain keywords in SAS that SAS automatically corrects based on the existing keywords which are stored in the SAS dictionary. So if you have written a word which doesn't match with the exact keyword, but if it sounds similar to that exact keyword, SAS is automatically going to correct that keyword. As you see here, again my program has executed. Let me clear this output window and log window and execute this program and show it to you this again. As you see here, though there is a mistake in my code, I have misspelled this particular keyword. Instead of proc, I have written pro. Still my program is executing. As you see this warning written in this log, SAS is assuming this particular keyword pro, okay, to be proc, and that way it is executing. Okay, so it is automatically correcting this particular mistake, compiling my code successfully and generating this output. This warning is a notification for programmer that he has misspelled a keyword. So though SAS is automatically correcting this error, but it is at the same time notifying the programmer that hey, you have misspelled a particular keyword. And SAS is not always going to correct your misspelled keywords. Here in this case, it has corrected this misspelled keyword only because it was sounding similar to this existing keyword proc. Similarly, there is a data step in SAS which is used to create a new data set. So I can say data and I can write some data set name that I want to create and then specify some input sources that I'm reading and creating this new data set. Now here in this case also, if you misspell this keyword, instead of DATA, if you write DAATA, which is a mistake, SAS is going to correct this mistake automatically because this keyword sounds similar to a correct keyword, that is DATA. So there are few such mistakes, misspelled keywords, which SAS will automatically correct. But as a good programming, you should always ensure that you have typed the correct keyword. So hope this basic elements of the SAS environment are clear to you. So this again, just to recall, this is the editor window where you will be writing code. This is your log window. This is your output window. Then if you see the left hand side panel, you have this results window which has two tabs, results and explorer. This explorer tab is something that you are going to use very oftenly. So if you click this explorer tab, You'll get these 4 elements called as libraries, file shortcuts, favorite folders, and computer. This is something that you'll be using very frequently, libraries. In SAS, we have a concept of libraries and library references. So basically these libraries are nothing but some existing containers or collections which have stored your different types of input data sources. So these libraries can be collection of data sets, they can be collection of raw files, or they can be collection of both this. It can contain your raw data sets, it can contain your SAS data sets. As you see my location, C drive, SAS Foundation, PRG1 folder, this particular location has files of different types. So let me show you this again. If I go to C: SAS Foundation PRG1 folder, you see different types of files stored at this particular location. So we have CSV files, we have DAT files, we have SAS datasets, and many other different types of files stored at this particular location. This particular location I can consider as a library, and this is something that I'm very frequently going to use in my programming because all my input data sources are stored here. So I'm going to access my data sources from this particular location. I'm going to transform them and perform some analysis and analytics on those data sets. Now as you see in my code, I have written a path to access one of my SAS data sets. Like this, I have thousands of data sets stored at that particular path which I am calling as a library. Now when you are writing a code in SAS environment, this is not a good approach every time you write this complete path to access your SAS dataset. We have a concept called as library reference in SAS, by which you can quickly and easily access all your SAS datasets which are stored at your library path. So not just cells, but 100 and 1000 more datasets that I have stored in this PRG1 folder, I can access them easily just by creating a library reference. So SAS is a collection of modules that are used to process and analyze data. SAS is a highly flexible and integrated software environment that can be used in virtually any settings to access, manipulate, manage, store, analyze, and report on data. It can be accessed virtually in any environment, meaning SAS does not recommend you to have a specific database or a specific operating system. So SAS can be used to connect any database, like it can allow you to connect to MySQL, MS SQL, Oracle, Access, Sybase, DB2. All these popular databases are supported by SAS environment. And the performance would be very consistent no matter which database you are connected to. So it, like some other vendors, it doesn't recommend you to have a particular database or a particular operating system to work efficiently. So you can use any operating system, say Windows or Unix or Linux or Solaris, and SAS gives you the same consistent performance. So SAS is very consistent across various databases and operating systems. A brief history of SAS. So the history of SAS dates back to the late 60s and early 70s as a statistical package. National Institute of Health, that is NIH, started a project to analyze the agricultural data of the USA. For this, they needed use of sophisticated computers to analyze data. North Carolina State University, that is NCSU, had high powerful mainframe computers. Programmers and econometricians of NCSU and 7 other universities teamed to develop this particular software. The product was created by NCSU student Anthony J. Barr. Software was named Statistical Analysis System. It seems NIH funding ended, but the project continued with the support from members in 1972. In 1976, SAS was incorporated as SAS Institute Inc. In 1980, SAS was rewritten in C language, enabling it to run on many different platforms. In 1990, SAS was Reoriented and developed for many vertical industries, NC State University launched the first Master of Science in Analytics degree program. In 2010, this was introduced as high performance analytical tool. Features like visual analytics, text mining, analytics, etc. were introduced. In year 2003, SAS 9.4 version was released in July 2013, which was in-memory and in-database processing capability. And massive parallel processing, that is SMP, cloud-friendly architecture was supported by this particular version. In its first version, in 1976, base SAS had 3 lakh lines of code written on punch card. Today it has 170 million lines of code, and all its functionalities are based on this particular code. These are the various functionalities of SAS. It can help you for information retrieval and data management. It can help you for report writing and graphics. It can help you for doing statistical analysis, econometrics and data mining. Also business planning, forecasting and decision support. Operation research and project management. So these are the tasks which are supported by SAS environment for SAS programmers. So SAS enables programmers to perform the following tasks of quality improvement, application development and data warehousing, where you extract data from several sources, you transform the data and load the data in data repositories like data mart and data warehouses. In SAS, as you saw in my previous code, the proc print code which I compiled and executed, output was written in the traditional SAS output window. But in case if you want to share this output with others, with your colleagues and other team members who does not have the SAS software configured on their machines, one can easily convert the output generated in SAS environment to various other formats like CSV, PDF, and XML, HTML, and it can be shared or distributed to various other team members, and they can quickly go through this report and take better strategic decisions. SAS helps you processing millions of rows and thousands of columns within a very short span of time. It gives you interactivity and support for various operating systems. It is compatible with various databases that we have. It supports large number of functions which are of different category, say numbers, statisticals, characters, which helps you transforming your data from one form to the other. It has comprehensive date and time handling functions that helps you manipulating the date and time related values. And there are bulk number of statistical and random number functions available in SAS, which helps you generating strong statistical models. These are the common platforms which are supported by SAS tool. So it's IBM, Microsoft Windows, Unix, Linux, OpenVMS Alpha. These are the operating systems which are very commonly used as SAS operating system environments. It seems there are 64 products of SAS which are available, covering business intelligence, statistics to predictive modeling. So as you see these 4 boxes, there are some SAS tools listed. Some of these tools I already discussed with you during my introduction session. So we have something called as Base SAS, we have Business Intelligence Dashboard, we have Data Integration Studio, SAS Enterprise Guide, we have Enterprise Miner, Information Delivery Portal, Information Map Studio, SAS Web App Viewer for Java. Then we have various SAS access tools like SAS ETS, SAS FSP, SAS GIS, etc. Okay, like this, if you see, there are several tools available in SAS environment which are designed for some or the other task and available for various domains for use, and that can help any business organization maximizing their revenue and profit and minimizing their cost. These are few applications of SAS. So we have this business intelligence domain, we have financial management, we have human resource management, we have customer relationship management, we have clinical domain, we have money laundering, text mining, and many more. These are the various applications or areas where SAS tool is used. Coming back to the program, SAS program again. So as I told you earlier, a SAS program is a sequence of steps that the user submits for execution. Now this program comprises of two major steps. So we have something called as data step and we have proc step. As I told you earlier, data step is used to create a new data set which will be used by various functions and processes of SAS for analysis and analytics. And proc step is some predefined procedure of SAS that helps you connecting to your data sources and generating some meaningful report or statistics. So this data step can be written on raw data or SAS data set, meaning you can create a new data set by using raw files such as CSV, TXT, DAT like files, or you can create a new data set by using some existing SAS data set which is in a very complex format. So a data step is mainly used to create new data set, and the input source which is used to create a new data set can be a raw file or a SAS data set. Then we have this proc step which helps you reading your data set, manipulating the data, generating a meaningful report or generating some meaningful statistics that helps your end users taking better strategic decisions. So data steps are typically used to create and update SAS data sets, and proc steps are typically used to process SAS data sets, that is sort data, manage data, generate reports and graphs, and do data analysis. There are three major ways by which you can invoke SAS and you can write a SAS program and submit the program for compilation and execution. We have something called as batch mode, where you write not just SAS code, but along with that you write some operating system code and submit both these codes for compilation and execution, where SAS code is compiled by the base SAS compiler and your operating system code is compiled by your operating system. Then we have this interactive mode, the SAS environment that I discussed with you, where you see the SAS editor, you see the log window, you see the output window, is called as interactive mode, where inside SAS editor you write your program. After completing the program, you submit the program for compilation and execution. When the program compiles successfully, output is generated in the output window. If there are errors or warnings, they are displayed in the SAS log, which programmer can quickly review and take the corrective action. This non-interactive mode where you write program is the one where you write your SAS code or prepare your SAS file in text editors like Edit Plus or Notepad, and then submit the program with .SAS extension and submit it to a SAS compiler for compilation and execution. But it would be very difficult for someone to work in non-interactive mode, because when they type the code, they will not be given hints or tips when they make mistakes in the keyword or when they miss some semicolon or when they commit some syntax error. So the kind of user friendliness that you see in interactive mode, you will not be able to get it in the non-interactive mode. So in non-interactive mode, you can use in any editor like Edit Plus or Notepad, record your SAS code, and then afterwards you submit this code to a SAS compiler for further compilation and execution. You can invoke any of these modes and submit your code for compilation and execution. When you are invoking SAS programs, this can be invoked in SAS windowing environment. To invoke the SAS window environment, execute the SAS command followed by this Windows option DMS exp to activate an window environment. You can do this processing interactively in line mode. With line mode processing, the programming statements are entered one line at a time. Data and proc steps are executed after a run statement is entered, or after another step boundary program messages and output appear on the monitor. we are mostly going to work in interactive mode. This is a sample SAS code. So SAS is a sequential programming language which has steps. Steps are sequence of SAS statements. As I discussed with you earlier, a SAS program is defined as collection of steps, and in each of SAS step you will see several statements which are terminated by semicolon. So as you see, in this particular program I have two major steps. There is a data step which is reading some source and creating a data set, and there is a proc step which is simply printing the data in the output window. All SAS statements in SAS program editor begins with some keyword. So all these lines that you see, this data and then some data set name and then in file and some input source name, okay, all these are the keywords. So every statement in SAS begins with a keyword and it ends with a semicolon. So please remember, all SAS statements begin with a SAS keyword and all SAS statements end with semicolons. This is an important rule because if you leave out a semicolon where one is needed, the program may not run correctly. This we have already seen in our previous topic, resulting in a hard to interpret error messages. These are some rules and guidelines which one must follow while writing SAS code in SAS code editor. Your code can begin in any column and can span in several lines. It should end with a semicolon. It is not case sensitive. SAS statements are free format. One or more blanks or special characters can be used to separate words. It can begin and end in any column. A single statement can span multiple lines. Several statements can be on the same line. So you can write your entire program in one line, or you can write every keyword in a new line. In any case, SAS will successfully compile your program and execute and show the report in the output window. While writing code in SAS editor, in case if you want to document your code, say you are implementing some important business logic and afterwards you are going to hand over this code to your other peers or colleagues who are there in your team. For their better understanding, you can document the business logic or the code that you are writing in SAS code editor by putting it within comment symbol. So it seems we have two comment symbols in SAS. We have a multi-line comment that begins with /* and ends with */, and we have a single line comment that starts with star and ends with semicolon. So if your comment spans in multiple lines, then that has to be embedded within the symbol /* and */. If it is one line comment, then you just begin with star and end with semicolon. And this way you can explain your program to others and they can easily understand your business logic. Not just for explanation, but at times if you want to discard or you avoid some of your code, even that code can be put within this comment symbol. So if you say, for example, you have written a SAS program where you have used several SAS statements and steps. Now you have modified some of statements and you want to avoid execution of certain statements which are a part of your program. Instead of deleting them, you can simply put them within this comment sign and they will not be compiled when you submit the program for compilation and execution. Advantage of this would be in future, again, if you need those statements, you need not write them again. They are available to your code. You just need to remove those comment symbols and submit it again for compilation and execution.